Alright class, today we're going to be dividing polynomials using factoring and synthetic division. Now factoring is the skill set we practiced today. Synthetic division is going to be something new. So let's jump into this first example. 3x squared minus 10x plus 7 divided by x minus 1. Now earlier today we said that our first step was to rewrite it as a fraction. Now this specific problem is already written as a fraction, but for the sake of consistency, I'm going to go ahead and write it again. Alright? Step 2, we're going to come off and we need to factor the numerator. So I'm going to show my scratch work over here. For step 2, I'm going to take my numerator, 3x squared minus 10x plus 7. And I'm going to factor that by sliding my 3 over to my 7 and multiplying. So x squared minus 10x plus 21. Now I can open my parentheses, start each one with an x. I'm going to put my 21 up top and my negative 10 on bottom. I'm looking for two numbers that multiply to 21 and add to negative 10. So that's going to give me a negative 7 and a negative 3. So x minus 7 times x minus 3. Now I'm not done yet because I start with step 1, which is slide. Then I factor. Then I have to divide by my leading coefficient, which is the 3 that I originally slid, and simplify. Now, the factor on the right, 3 divided by 3 is 1, so that becomes x minus 1. But on the left factor, 3 does not go into 7, so I'm going to slide that 3 right in front of the x, and that becomes 3x minus 7. Now that it's factored, I can slide that back out as my numerator. So 3x minus 7 times x minus 1 divided by, my denominator didn't change, so that's x minus 1 as well. Now step 3, in class we factored the denominator as well, but in this specific problem we don't have to. So we're going to skip step 3 and we're going to go to step 4. I'm going to go ahead and rewrite my problem again. 3x minus 7 times x minus 1 divided by x minus 1. And I'm going to simplify it by canceling out anything that repeats. So x minus 1 divided by x minus 1 equals 1. So they cancel each other out, and I'm left with just 3x minus 7. Alright, so now that we figured out the answer to this problem using factoring, we're going to work the exact same problem using synthetic division to see if we get the same. So I'm going to start using this little contraption on the side over here. This is going to help us organize our problem, and that's what we're going to use to solve and to work through this problem using synthetic division. Alright, so I'm going to start by identifying all of my coefficients in my numerator. I'm then going to take those coefficients, starting with the highest powered one, which is going to be the 3x squared, and I'm going to pull it over here. 3, and then I'm going to go down the line, negative 10 and 7. Then I'm going to look at the number in my denominator, and I'm going to take its opposite and put it out front. So the opposite of negative 1 is a positive 1, and that comes out front. Now we get into the actual using of this. So I pull the 3 straight down, and it gives me a 3 out front. I then multiply 1 times 3 to give me 3, and I put that number right here. Negative 10 plus 3 leaves me a negative 7. And then again, I multiply negative 7 times 1, which gives me a negative 7, and I put that right here. And 7 minus 7 is 0. That's going to be my remainder on this specific problem. So now, when I'm recording my answer, I'm going to start with my number in front. So this 3 is going to come down, and it's going to have an x with it, but the x is going to be 1 degree lower than our highest in our numerator. So we saw that our highest power is 3x squared. So when I go 1 degree lower, it's simply just going to be x to the first, or x by itself. Then I'm going to pull out my negative 7, and it's going to be minus 7, and it's got to be 1 degree lower than the next x up top. So then we went to negative 10x. And if this is x to the first, 1 degree lower is x to the 0, which eliminates the x altogether. And so my final answer is just 3x minus 7. Now, I know it seems a little bit complicated, but it makes much more sense as long as you keep practicing it. And just to compare that we got the exact same answer on both, here it is solving it with factoring, 3x minus 7, and here we solved it with synthetic division and got 3x minus 7. So, I'm going to show you another example using synthetic division. Alright, so we have m squared minus 7m minus 11 divided by m minus 8. So I'm going to grab my coefficient of 1, m squared, my coefficient of negative 7, and my constant, negative 11. Then I'm going to take the opposite of this number and place it out front. So a negative 8 becomes a positive 8. And then I start the process all over again. So the 1 comes straight down, stays a 1. 8 times 1 gives me 8. I bring that right here. Negative 7 plus 8 is a positive 1. Again, 1 times 8 is 8. And I bring that 8 right here. Negative 11 plus 8 is going to leave me with a positive, or a negative 3, remainder. Now, this time we have a remainder, so it's going to be a little bit different when we record our answer. We're still going to start from the front, which is 1. And our m is going to be 1 degree lower than the highest in the numerator. So the highest in the numerator is m squared, so this one stays m to the first, plus 1 m to the 0, because we're counting down degrees, minus, and this is where our remainder comes into place, minus 3 divided by our denominator from up top. So it's going to be m minus 8. Now, there's a lot of extra information in that one, so we can eliminate what we normally don't write. We normally don't write a leading coefficient of 1, and we normally don't write a power of 1, so that first term would just be m. Again, we don't write a leading coefficient of 1, but m to the 0 is 1, so this becomes m plus 1. And then the remainder is exactly as you see it, minus 3 over m minus 8. And that would be our final answer. Alright, now I'm going to show you another example, but this one's a little bit different. If you look up in the numerator, we have 4a squared minus 3. We don't have an a by itself, so what we're going to do is we're going to consider this 4a squared plus 0a minus 3. And it's still divided by a plus 4. So we're going to repeat our process now, but you have to remember that that 0 goes there if I have a variable to a degree missing. So I fill in my coefficients. 4, 0, negative 3. And I take the opposite, so a positive 4 will give me a negative 4 out front. Now I begin my process. I bring down my 4. 4 times negative 4 is negative 16, so I bring that over. 0 minus 16 is negative 16. Negative 16 times negative 4 is a positive 64. And now negative 3 plus 64 is a positive 61, and that's my remainder. So now I write it. 4. And since my highest degree in the numerator is a squared, this is a by itself. 4a minus 16 plus my remainder of 61 over a plus 4. Alright, we're going to look at one more problem that looks much more complicated than it is. If you follow the exact same steps, you can complete this problem just like the one before. So, I'm going to start by identifying all of my coefficients and bringing them in. 2a to the 4th plus 3a squared minus 5a plus 1. Now, if you look back, you'll notice that I do not have an a to the 3rd. So I have to put a 0 in between my 2 and my 3 to represent 0a to the 3rd. Alright? And now I have to find the opposite of the number in the denominator so that negative 2 becomes a positive 2 when I bring it outside. And we start the process. 2 comes down and stays. Now 2 times 2 gives me 4. So I put a 4 here, and 0 plus 4 leaves me 4. Now 2 times 4 is 8, so I bring my 8 here. 3 plus 8 is 11, so I bring it out. 2 times 11 is 22, so it comes here. Negative 5 plus 22 is 17, and 2 times 17 is 34, so I bring my 34 here. And 1 plus 34 is 35, so that's my remainder. Now when I'm recording my answer, remember I just have to start with a variable to 1 degree lower than my highest. So my 2 is going to be with an a cubed, since my highest in the numerator is a to the 4th, plus 4a squared, plus 11a, plus 17, plus my remainder of 35 over a minus 2. And that would be my final answer. So, don't let big problems intimidate you. Don't let them confuse you. When using synthetic division, it is simply bringing your coefficients and identifying any missing ones that might be there. Thank you all, and have fun practicing.